Hello everyone. Good evening. It's 5 p.m. now. So in the previous question, the question gives us the direction where the current is flowing is towards the right for I1, I3 is towards the right, I2 is upward. So what if the question did not give us any information regarding the direction that we want to start and the current flow? Let's say they give us in this form. So in this question, in this form, we can just assume any kind of direction that we want for the current to flow. So let's say I create I1 is equal to this direction, I3 is in this direction, and I2 is in this direction. As long as we have current entering into the junction and exiting the junction, that is very important. Instead of all pointing towards this point, it is an invalid form of expression. We need to have something in and something out. So this is in, this is out. Alright, so let's say that previously we start with this direction, and let's say our direction change into this direction and this direction. Actually, it doesn't matter which part, as long as we have the correct notation for this symbol, the symbol for the terminal of each component. Alright, let's begin our discussion. So first thing first is we have determined the direction, and we have determined the direction that we want to, where we want to look. And then the next thing is we need to write the notation in front of the component. So since the current is flowing into this direction, so this must be positive terminal and this must be negative. Current flow into this direction. Since this is battery, we don't need to be bothered. The long bar here corresponds to positive terminal and the short bar here corresponds to negative terminal. And this is resistor, so the current is flowing into this direction. So this must be positive, this is negative. Now another things that we need to don't need to be bothered is despite this is positive terminal and the current is flowing into this direction, we assume it is okay. It doesn't matter. As at the last answer, we will get I2 negative. We have answer for I2 is negative, so this corresponds to the current is in the reverse direction that we have put previously. So we continue. Current flow into the direction, so this is positive, this is negative, and so on. So the next thing you need to do is we need to use the Kirchhoff current law or the junction rule. So we know that in this part we see that I1 and I3 is entering this junction. So current entering a junction is equal to current exiting the junction. So I1 plus I3 is equal to I2. Later on we need to modify this. So let's apply our Kirchhoff voltage law to make expression for this loop. This is loop 1, this is loop 2. For loop 1, let's begin at here, at this part, move along. This is reverse direction, so we move in the reverse direction, counterclockwise. So here we meet the resistor 4, we meet the negative terminal, so we need to write negative. The current flowing into this resistor is I2, so 3I2. And then we meet the negative terminal of this battery, so negative 20. We move along, and then we meet negative side of the R3. So we need to put negative sign, and the potential difference is 85 multiplied with I1, since the current flowing into this component is I1. And we move along, we meet the positive terminal of the battery. Next we meet the negative terminal of this resistor, so minus 10 I1. And then the last component is R1. We meet the negative terminal, so negative 12 I1. So this overall equal to 0 according to the Kirchhoff voltage law. So when we simplify this expression, what we'll get is negative 27 I1, and then minus 3 I2 equal to 0. So this is our first expression. Our next is we need to look at the second loop.